Let's look at another typical example over here. We want to find the approximate value of tangent 46 degree. So we want to say, what's going to be the tangent value of 46 degree approximately? And you can see the meaning of this problem because we know tangent 45 degree. Of course, that's going to be tangent pi over 4, and that's 1, right? That's something we know. But we want to know what is tangent 46 degrees. We know this is approximately 1, but 1 point something. So this one over here is approximately 1 point something over here. And that's what we are trying to do. And because we know the value at 45 degrees, so we know A is 45 degrees. But on the other hand, remember in calculus, we always use radian. We don't use degree measure because otherwise our derivative formulas are not correct. So over here, we have to turn this one over here into radian. And we know 45 degree is pi over 4. And then 46 degree is pi over 4. Plus pi over 180 because 1 degree is pi over 180, right? That's the one. So now we can recognize in this problem over here, we need to actually find both function and the points. So we have over here, we can say, well, f of x is going to be tangent x. That's going to be good. And we know a point over here is pi over 4. And x has to be around a, and that's going to be x over here. We have pi over 4 plus pi over 180. Okay. For the moment, we don't really need a calculator. We don't need to know exactly what this value pi over 180 is. And just keep it like that. So remember, now what we are doing is that f of x is really tangent pi over 4 plus pi over 180. This is 1. And this is going to be approximately f of a, if you try to remember the formula. This is a derivative formula in different form, and x minus a. Okay. Just remember the formula carefully. And then right-hand side, we can know f is tangent. So this is going to be tangent pi over 4. Let's write down first. And plus the derivative at pi over 4. Now, this is something we did not emphasize. What's going to be the derivative of tangent x? You can use the quotient rule to find it, but this is 1 over cosine square of x. Some of us remember this is secant square of x. So the derivative at a point pi over 4, so this is going to be 1 over cosine square pi over 4 over here. And then pi x is pi over 4 plus pi over 180. So we know really x minus a over here is pi over 180. Okay. And that's the approximate value. Now we can find it. We know that cosine, the cosine pi over 4 is square root over 2, right? So it's square, or you can say 1 over root 2. So its square is 1/2. And then we have over here, this is 1, and then plus 1 over this square over here is 1/2 and times pi over 180. So this is 1 plus pi over 90. And that's the approximate value. So we have tangent 46 degree is approximately 1 plus pi over 90. Let's go back to look at how we found this value over here, approximate value over here. First, this is first thing. We recognize that tangent 45 is easy to calculate. So tangent 46 degree is approximately tangent 45 degree, which is 1. And then we call this 45 over here a, pi over 4 using radian. And then f of x is the one we need to approximate, and then we have x is pi over 4 plus pi over 180. And then we use the approximation formula over here, the linear approximation formula over here, and calculate the function's value and the function's derivative, at this point A, and then multiplied by this difference over here, and that will give us the approximation. Let's look at another more abstract example over here, but it's easier to do since we don't really have a special value. We just need to find a formula. So we want to approximate y over here. So f of x is 1 plus x to the power alpha. And we want to find out what f of x is approximately the value when x is approximately 0. Okay. So that means our a is equal to 0. That means we have f of x is approximately f of 0 plus f prime of 0, and x minus 0 is simply going to be x. So this is 0 over here. It's 0. So that's the formula we are finding, the linear approximation formula. And so we just need to find the value. We know f of 0 is going to be 1 plus 0 to the power alpha, and that's going to be simply 1. 1 to the any power is just 1. And derivative, we can take derivative. Y prime is going to be alpha 1 plus x alpha minus 1. So f of derivative at 0 is going to be simply alpha times 1, and that's going to be alpha. So the linear approximation we have is the following. 1 plus x to the power alpha is equal to 1 plus derivative is alpha and times x. And that's a very useful formula to have because it's true for all alpha over here. There's no exception. Alpha is a constant. This is true for all alpha. Okay.